Hello everyone, this is the video lecture for Calculus 1, section 6.5, average value. And let me go ahead and give you the formula right now, because that's what I'm going to do. So I've got 1 over b minus a integral from a to b of f of x dx. There you go. There's your formula, and we're going to encounter mean value theorem here later as well. I think that's what it's called, but it's really not too big of a deal. It's cool. We're going to do it. It'll be great. So are you ready for some integrals? Awesome. I have f of x is equal to 3x squared plus 4x. I'm going from -1 to 5. Okay. And they say find the average value. So you got 5 plus 1, right? Don't you have minus a negative? Integral from -1 to 5 of 3x squared plus 4x dx. That's all we're doing. And if you know how to do this, then you can skip ahead. Seriously. If you don't know how to do this, then, well, I would be actually kind of sad, because at this point you should be able to do it. Plug it in. -1 as well. 29. All right, there you go. You didn't skip ahead really that far, did you? 65003. I think they're just wanting to test us. That's what it is. They're wanting to test us to make sure. Do they really know that formula? I mean, it's a cool thing. I mean, to find the average value, right? Hey, I wonder right here, what's the average value? No, it's good. I mean, it's easy stuff, obviously. This is just, I'm just going and doing it right in front of you. I don't know what else to say. There's the formula. You plug it in. So we got a pi in the bottom, so 1 over pi. And then my 3 can come out, actually, so that's cool. Integral cosine is a sine. And we're going to go from -pi/2 to pi/2. When you plug this guy in, you get a 1. When you plug this guy in, you get a -1. But because it's two negatives make a positive, they're going to double. So it's 3 over pi plus 3 over pi makes 6 over pi. Oh, wow. That was invigorating. That was so wonderful. I think we've had a good run here, you and me. We've gone through a lot together. Yes, I know, you've been watching every one of my videos up until this point. And now we're here at the end. And all my sarcasm and silliness and sometimes frustrations, it's all going to be over until next semester. There's a 2 distance between those guys. And so I'm just going to integrate this. I would say that this is actually something to talk about, because that's fun. I'm going to do u substitution. du is 3x squared dx. And I'm going to do my flavorful division thing. And so then I got x squared over u squared du over 3x squared. Cancel, cancel. The 3 can come out here, make a 1/6 now. And so I got u to the -2 du. Whew. My hand hurts, sorry. I mean, I can only write so fast. So add 1 to the power, divide by the new power, and we're going from x equals -1 to x is equal to 1. Very important to reconvert that. X cubed plus 8 all to the -1, which technically means it's in the denominator. When you plug in your numbers, as usual, you get an answer. That's right, and there's your answer for the day. Wow. Did you want another one? Did you want more? Sure. Okay. I mean, it's on my list. Might as well do it here, right? Do it again. So, okay. Let's do it again. So exciting. And so integral from 0 to pi of this formula thing. Not very good. Not very good at my handwriting here, sorry. Okay, so I'm going to have to integrate this stuff. Obviously, the 1 over pi doesn't really do much. This makes a negative cosine. This one's interesting. I want to pause for right quick. Just pause, okay, because my hand hurts. So when we're integrating, what we're going to do is divide by the derivative of the inside. You know, like kind of like chain rule for derivatives, and I already talked to you about this. Chain rule for derivatives. What's the derivative of the inside here? That would be a 2, right? So you multiply by 2. Well, because we're integrating, we're not going to multiply. We're going to divide. We're going to divide by the 2. And so what actually happens is technically this sign here, this negative sign, is still going to turn into a positive cosine, okay? But now it's going to be 3 divided by 2. And again, just like in chain rule, you leave the inside alone, okay? This right here, this is Cal 2 business. I mean, it's not really. Obviously, it's just Cal 1 integrals and stuff, but that's how I treat it. I say, you know, we're moving on to Cal 2 now here in a minute, and, well, you could start doing this without having to write it out every time. Anyways, I just had to make that little spiel because my hand was hurting and I wanted to just rest it. Moving on. Plugging in the pi and plugging in the 0, both of those actually yield stuff. I got 12 over pi in the end. If you ever wonder how I did all that, it is simply a calculator. And me particularly, I'm fast at typing. So I literally just type this thing out with a pi in there, and then I say minus sign and type it all back out with a 0 in there. There's much quicker ways, but that's just one way to do it. Now, that's part A. Oh, no! Part B is a little different. It says, find the C values. Find the C values where f of C is equal to your F average. And I think that's called the mean value theorem. It's been a while. I don't have it in my notes here necessarily. But it is actually a pretty cool technique that I want to show you here in just a second. Now, let me just show you how to get this thing done. Basically, I'm replacing my original one with X's. I'm actually saying those are C's, and this should be equal to my average value. Okay, so I know I have X's, but that's technically the C, okay? But I'm leaving them X's on purpose because I need to solve for X. Now, pause for a second. Pause, pause, pause. Look at this. Look at that equation and tell me what you would start doing to solve for X. No, I'm serious. Say it out loud. I'll listen. So sine of 2x is a 2 sine times cosine, right? And then I can factor it out at 2 sine, and then I can solve for x over here and solve for the cosine there, and da-da-da. One of those is going to be it, maybe. Actually, in fact, I'm seeing 2 answers come up. That would take for a long time. And they want decimals. They even said use technology. If I could spell it, that is. And you know what that means here in this class? It means Desmos. That's right. Go to Desmos, type this dude in with the x's, and go and find when it crosses the x-axis. It's 2 times 1.238 and 2.808. You are done. Now, just as a small trick that I've been learning myself, if this doesn't actually let you click one of these answers, you have 2 options. You can zoom, or you could do the minus trick. Okay, there's 2 tricks. So zoom in, scroll, 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 and eventually you would get to these numbers. Or the minus trick is that you would change this to a minus sign, and Desmos interprets it as a graph instead of an equation, and I believe most of the time you would just be able to click on these numbers and it would show you the 3 decimal places without any worries. So check that stuff out. I mean, I'm not saying that we're going to use Desmos for every single problem like this, but they even said use technology, so I'm doing that, okay? Now, let's talk about what's going on in reality here, okay? So, average value, mean value theorem, and all that stuff. Okay, so let's just say I had some kind of graph like this. This is not the same graph. This is completely separate. I got some kind of graph like there, and I want to know where's my average value, my average height. And I don't know. So it goes up until, let's just call that 100, and then it comes back down to 0. I don't know, around 50 or something maybe. I don't know. So let's just call it around 50. Just because I'm being generous, it's probably closer to 40 or so. Because I mean, I don't know. But what you're going to have to do is you find the area, and then you take that area and you divide it by the interval, and it just gives you the. Now, why is that important? What is the importance of this kind of stuff here? So here's an example. Okay, I'm going to give you a real world example why this is actually important. Okay. Let's say that there's a road. Let me make a road for you because I'm a professional road drawer. And so you're driving down the road, obviously going this way. And there's a cop standing over here. I'm going to put little lights on him, okay? There's those light signal things. And he's standing outside of his car with the radar gun. And you're just cruising. Let's just say you're cruising at 60 miles per hour. He's like, okay, well, that's the speed limit here. Let me just do 60. So, okay, keep going. And then as you keep going, way down over here, there is another cop here, and he's also beaming you, and he detects you going 60 miles an hour. Cool. He goes, and pulls you over, and you're like, okay, whoa, I was going to speed limit. But here's the thing. These guys have walkie-talkies or whatever they got. And so they could timestamp you. Let's say time equals 0 whenever he hits you with the radar. And over here, there's a timestamp of, I don't know, 10 seconds or something like that. But the distance to get here is some X distance that would say that you had to get here from here to there in, say, 20 seconds. So they already said if you're going 60 miles an hour and you're going from here to here, it takes 20 seconds to get there. They already measured it. But then he caught you, and it was only 10 seconds. And yeah, so basically he's seeing you radar at 60, and 60, apparently you're following the speed limit, right? But in here, when you're in this zone here, you're going like 100 miles an hour, and they know that. Why? Because of the mean value theorem, because of this average stuff. And so what it could be is that they find out this medium, this I don't mean here is at 60, let's say, because everyone's going 60, that's the average. And the time it takes, your distance, you're dividing by the distance, blah, 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 blah. This is just a side of calculus that you never thought of. So there you go. One other thing, and I know I'm just going off tangent now. You ever notice those little black strips in the road, and you run over them, and they're counting how many cars are going back and forth? Cool, okay. Now, if you had 2 black strips in the road, you ever see those? Yes, I know they're counting direction, because you thump over this before the next one, right? But if you space them just correctly, you can tell how fast you are going. So don't speed over those things. Calculus in the real world. 6, 5, 0, 1, 0. I have f of x is equal to x minus 4 squared from 3 to 6. And they say, find the average. And I say, okay. There's a 3 distance between these guys. Integral from 3 to 6 of this integral formula function thing here. And there you go. You could do the u sub stuff, but I know you're a little bit more advanced than that at this point. And so you just say, you know what? Your u is going to be du's dx, so I don't really have to change anything. Add 1 to the power divided by the new power is sufficient in this problem. Plug in the 6, plug in the 3, and you know what you get here? You get... Oh, that is so weird. You get 1. There you go. Woohoo! Part B. So it says, find the C values where it's equal to the average. So solve for x again. Well, okay, so, sorry, I'm going a little off track there. I got x minus 4 all squared is equal to 1, solve for x. So yeah, you square root both sides. And when you square root both sides, you have a plus and minus. Be careful there. And so we got two numbers here, 3 and 5. There's your answers. Okay. 65014. We got f of x is equal to 7 plus 10x minus 9x squared. We're going from 0 to b. Oh, this will be great. And my average is equal to 8. I really like this problem. It's pretty cool. So we got this upside down parabola thing. And I don't know. It's not starting at 0. But let's just say it's like this. Actually, it's probably doing this. And so from 0 all the way out until b, I don't know. Let's just call b right here. I want to make sure that the average height along that time span is an 8. Solve for b. And so, okay, that would mean that I have 8 equal to 1 over b integral 0 to b of this stuff. So this is a little unorthodox, but that is okay. Every time you see a 6, go ahead and think it's a b. Yep, that's my handwriting. But you won't have to put up with my handwriting here soon. And then you're going to take Cal 2 and you'll have to put up with it again. You've become a professional messy handwriting reader over these months. And so the 0 is going to cancel everything. The b gets plugged in, and it's literally just replacing your x, and that's it. And so you got 8 is equal to 1 over b, and then 7b. We got a 5b squared, and then a minus 1/3 b cubed. And you can cancel a b from each one of these. Notice that I'm going to divide that into each one of them. So 7 plus 5b squared minus 1/3 b. Whoa, it's not squared. It's just a b. Minus 1/3 b squared. And you can even... Wait. Why is it 1/3? That's a 9. It's a 3. It's a 3. Okay, sorry. Watch to the end. So, minus the 8 on both sides. And what you actually get is a very fun one. Negative 3b squared plus 5b minus 1 is equal to 0. Solve for b. Do you know how to do that? Do you know how to do this? It ain't factoring. Got it. It's quadratic formula. That's right. We had to have one right before the end of the class. Had to. I'm kind of sort of plugging it in. Okay. So I got my 81. 3 negatives make a negative in the end. That's going to be a 12 all over negative 6. Why negative 6? Why a negative 6? Oh. Yeah. This is fine. Yeah, this is good. This is good. And you can basically eliminate all the minus signs and all that kind of stuff, whatever. I had done it differently on my notes here. And it's 5 plus or minus the square root of 13 all over 6. Why did I get a 9 here? That's supposed to be a 5 squared, right? 5? Sorry, so that's a 25. I just can't even do a quadratic formula right. Ugh. Okay. 2 problems left. 65016. This one's got some crazy graph thing. Whew. This is a 12. And then we got something here at 8. And then we got something here at 4. And they say, use the midpoint rule. Oh, great. That's what I wanted to do. Yeah, so there's no way to get around it. Basically, what you're doing is looking at the midpoints here for their heights. Okay, and so here you have 2 distance, a 6 distance, and a 10 distance, and your heights are 20 and 45 and 47. Okay. Sweet. And then times 4, and you got 488. So what's going on here is you just found the area underneath the curve, midpoint rule, integral, whatever. So that's basically your integral f dx, okay? Just think of it like that. It's just a rough approximation. Well, they want v average, whatever v is. I guess it's just, this is v. Okay, great. So that's v. And so the average is going to be divided by the interval, which goes all the way to 12. So 1 over 12 times that 488, which makes 40.667. Their answer is only 40. So I must have missed one of those guys along the way. It'll probably be fine. It'll probably be fine. Oh, they have a part B. Isn't that awesome? It says, at what time is the instantaneous velocity equal to the average velocity? Oh, yeah. Okay, we can do that. So notice that we have 40 is my answer. So I'm going to go to 40 right here. And I'm just going to approximate the best I can. Boom. Bam. And, yeah, I'm hitting it at about, 5. That's awesome. That sounds perfect. And so part B says, when is that ever going to happen? And you put it a 5, just like I did. Oh, it's not 5. It's 5.1. Yeah, they're really picky today, okay? No way, it's 5. Last problem, 65017. Let's get it over with. Capital T is equal to 42 plus 17 sine of pi over 12t. And they're saying that t is the hours after 9 a.m. And they say find the average from 9 a.m. to 9 p.m. How many hours is that? 12 hours. Very good. And so t average is going to be 1 over the 12 integral from 0 to 12 because that's what they're wanting. And then we just plug this guy in. Desmos. And then, you get your answer and you're done. Did I just say Desmos? Did I? So I just want to you know what? We're going to finish this one strong, guys. We're going to finish this one strong. So we got 42t. That's easy enough. The 17 stays in the front. Instead of multiplying by the derivative inside, I'm going to divide by the derivative inside, thus flipping it. My sine is going to go to a negative cosine. So that's actually going to be a negative cosine, and you leave the inside alone. Okay. And you're going from 0 to 12. So 0 is actually going to yield something right there, so you got to be careful when you do that. Or, well, you could just use a calculator. I got 52.83, and they are satisfied with 53 degrees Fahrenheit. That's their answer. We're done. Done with all of Calculus 1. Whew. Now, see you back in Calculus 2. Thank you very much. Have a great day.